Okay. So, exponent laws. Before we start doing the examples in the textbook, we are going to review exponent laws, 3 of them that you would have learned in grade 9. Okay, I'm sure your teachers taught it to you. You've all had wonderful teachers in grade 9. Exponent law number 1 is when you are multiplying exponents together, or bases, I should say, sorry. So say you have that power, a to the n, and you multiply it to another power that has the same base. So they're both a's, or 4s, or 10s, but they're the same. Who remembers what you can do with the exponents in this case? This is the first exponent law. Crickets, it's crickets. Well, exponent law number 1 says you can keep the base the same, so you don't actually multiply the base together, it just stays whatever it is, and you add the exponents together. Does that ring a bell? Oh boy, today should be fun then. Okay, so that's law number 1. You add exponents together when you're multiplying. Law number 2. Similar, but now we're dividing. So again, you have 2 bases that are the exact same. So the big numbers, you have 2 different exponents. And when you're dividing, who remembers what we can do with the exponents, Emily? Subtract them. So again, the base stays what it is, and you can rewrite it as n minus m to subtract the exponents. And law number 3, say you have a power, so a to the n, but then it's raised to yet another power on the outside. Who remembers what we can do with those 2 exponents? Hayden? Yes, you times it. See, like Hayden said, you send it in and multiply it, okay? And there you go. So those 3 exponent laws are going to help us with every question today. There's one extra one I just want you to remember. Anything to the power of 0 equals, you guys remember? Not itself, no. Anything to the power of 0 equals 1. Again, you would have learned that in grade 9. It was a long time ago. I forgive you. But now you know them. Okay? They're on that poster right there. I know it's French. The first one that says Les lois des exposants. It's the first 3 there. It's the same in English as it is in French. Okay? Those laws are the same. Okay, so now we're going to boogie into these examples. So I'm first going to start with example B on page 238. Okay? So examples start now. So this is our first example, but I'll just put in brackets here. This is B from the textbook. If ever you want to look back in the textbook and look at them again. Okay, so this is what we're going to do. Copy this down correctly. Big square bracket, and then a little bracket, -3/2. Close the bracket, all to the -4. Close the big square bracket, and then that's also to the 2. Not done. We're going to then multiply that to another big square bracket, another round bracket, another -3/2. Close the bracket, all to the power of 2. Close the square bracket, all to the power of 3. So take a second, make sure you've copied that down correctly. Okay, that looks nasty, doesn't it? A little bit scary. We got fractions, we got 2 types of brackets, we have negative exponents, we have positive exponents. Blech. But guess what? Our exponent laws will help us clean this up so fast. Okay? So if you look at this first bracket here, you have -3/2 to the -4 to the 2. I don't know about you, but I see law 3 right there. Law 3 is when you have two exponents side by side, kind of, you can multiply them. And I have the exact same scenario over here. So I'm going to rewrite this now as my base doesn't change. It's still -3/2. But now my exponent, because I'm multiplying those guys together, is -6. And the square brackets can now go away because those square brackets were just serving as separating that 2. Okay, it's kind of like the separator between the 4 and the 2. Now that we've brought them together, those square brackets can go away. We're going to do the same thing over here. So again, the base doesn't change, -3/2. Use that exponent law of multiplying those guys together, and you have a 6. Oh, did I do something wrong? That's an 8. That seemed wrong when they were both 6s. Sorry. But you guys are sure alert, all those hands going up. I know you're awake. I did that on purpose, actually, to see if you were awake. Okay, now, we're not done because I see yet another exponent law. Which exponent law do you think I could use now? My bases are the same. They're both -3/2. I am multiplying together. So Emily, what do? I add the exponents together. That's law number 1. So after I do law number 1, the base does not change. It's still -3/2, but now the exponent becomes -8 plus 6, which is -2. So here's the thing. I still have a negative exponent, but not to fear, we know how to deal with that. When you have a negative exponent outside a pair of brackets with a fraction on the inside, you're just going to flip that whole fraction upside down. It's still negative. That negative doesn't go away, but the negative on the exponent will, because we flipped that fraction. And now all we're doing is squaring that. So what's 2 squared? 4. What's 3 squared? 9. And when you square something that's negative, the negative goes away. And we're done. So that big whole ugly thing became just 4 on 9 by just using our laws. Okay. All right, example number 2 is going to be C from the textbook for those at home. So this is what C looks like. It is in brackets 1.4 to the power of 3, then another 1.4 to the power of 4, and then another 1.4 on the bottom to the power of -2. So don't be intimidated because the exponent laws will save you. You just have to ask yourself, which exponent law can I use right here to clean this up and make it look not so scary? Who has a suggestion for me? Yes, Blessing. You got it. So you even said both steps. The first step, though, is just to add the tops, right? Up top, you have two bases, 1.4, multiplied together. So on top, like Blessing said, we're just going to add those together. I have 7 now. And then on the bottom, I still have that 1.4 to the -2. Now, like Blessing said again, okay, now I still have two identical bases, 1.4, but now they're just being divided. So now I would subtract them. Now be careful here. This is where the mistakes happen. You are going to take the 7 and you're going to subtract the already -2. So what are you actually doing? You're actually adding, right? See what I mean? Yes.
So what I did.
Exact same thing. So what Emily did was she took this down here and said, oh, it's negative, move it up top. And when it becomes up top, it becomes positive. And then what's 7 plus 2? 9. Regardless, we get the 9. So that's kind of a moral of the story for these guys. There's so many ways to do the same thing. And it doesn't matter to me. It's whatever way makes sense to you. So regardless, we are going to get a base of 1.4 to the positive 9. And then in your calculator, you just do that. 1.4 to the power of 9 equals 20.7. All right. We good with that one? Next one. This is example 3, but it's D from the textbook, page 238. And it looks like this. So we have a big fat fraction. On top, we have 7 to the 2 over 3, all divided by, down low, 7 to the 1 over 3, and that's multiplied to another 7 to the 5 over 3. Close that big old bracket and put it to the 6. Wowza. Okay, looks scary, but have no fear, exponent laws are here. So whenever you have a big fat bracket like that with lots going on, ignore that 6. That 6 on the outside, we're going to deal with him later. Inside the bracket, what can we do? Hayden? No. Not times them? No. Add them. Yes, add them. So on the bottom, that's law 1, isn't it? You have 2 identical bases that are multiplied together, so we can add the exponents together. It just so happens that the exponents are fractions. So if I do that over here, I take my 2 fractions, which are 1/3 on the first guy, and I'm going to add them to 5/3 from the second guy. When you add fractions, you need common denominators, which you already have. How groovy is that? Easy. So you just add the tops, 6 over 3. Now, that reduces to 2, but we're going to leave it as a 6 over 3. And I'll explain why in a second, or maybe someone else can see why I want to do that. So if I rewrite this, up top, I still have that 7 2/3. He's just patiently waiting. But then down low, that 7 stays a 7. You do not make it a 49, and that is a very common mistake. You do not go 7 times 7. The law says you keep the base the same, and you just change the exponents to that 6 over 3. And then don't forget 6 on the outside. Now, who can tell me why I left that as a 6 over 3? A jock? Right, because now the next step would be to use law 2, which says subtract the exponents, because again, you have the same base, 7 over 7, they're being divided. So you can subtract the exponents. So I take that one up top, which is 2/3, and I'm going to subtract off 6 over 3. So that's why I left it as the 6 over 3, because as a jock said, I need common denominators again. 2 minus 6 up top is -4, and that 3 on the bottom stays a 3. So I head back, and I now rewrite this as just 1 big fat 7 to the -4 over 3, but it's still to the +6. So now we have to deal with that 6. We've simplified the bracket as much as possible. So this right here, you guys, well, that's law 3, isn't it? When you have an exponent butted up against another exponent, law 3 says we can multiply them. So I'm going to do that over here as well. I have -4 over 3 multiplied to a 6. Multiplying's the easy one. You don't need common denominators. We just imagine that this 6 is over top of a 1. You multiply the tops together, -24, and you multiply the bottoms together, 3. Let's reduce that to just a -8, right? 24 divided by 3 is a nice fraction. It works out to be 8. So now I go back here again, and I rewrite this as 7 to the -8. I'll draw an arrow. That's where we did that work to get -8. Okay, well, sorry guys, we are not done because we can never have negative exponents in an answer. We know how to deal with negative exponents. So I'm going to take that 7 and send him down, right? That's how we deal with negative exponents. So the 7 now gets sent down to the denominator. And what do I put up top? A space filler of 1. And then all you have to do is just solve that. 7 to the power of 8. Oh, I left my sheet over here. I don't want to undo my headphones. So 7 times 7, 8 times, or some of you have an exponent button. 5, 5, 7, 6, 4. Oh, I want that much money. That's how much money I want to win, you know? That'd be sweet. $5,764,801. Sorry guys, I wouldn't be here tomorrow if I won that much money. Be buying a cabin where there's no COVID. Okay. How are we doing? Ish. Okay. I am now on example 4. I'm going to have to move this down a little bit. We're going to do, I think, one more. We'll see how we feel after one more. Now my mouse isn't working. Okay. So now this is example 4, and I've done B, C, D. I'm going to just kind of fly by the seat of my pants here and do a different one from the textbook. Okay, so number 4, copy this guy down. And you guys are going to try this one yourselves. So big square bracket. In the bracket, -4 on 5. Close that little bracket. That's to the 2. Then close the square bracket. That's to the -3. Divided by big old square bracket. -4 to the 5. Close that round bracket. It's to the 4. Close the square bracket, and it's to the -5. So this is very similar to actually the very first example we did. So if you want to kind of head up to your first example to get a refresher, the big difference being though, that it's a division in between the two. So I'll just give you 2 minutes or so to try it. And if you're listening at home, you can just fast forward a couple minutes. And this answer, I'll just let you know, it has a really big exponent in the end. So once you get to that, you can just leave it there. You don't have to solve. I won't give you a hint. I won't tell you what it is. But in the end, you'll get something to the power of a very large number. Just stop there, okay? Your calculator couldn't even do that, I don't think. Is there anyone who's done and who's brave enough to share what they got? No? Yeah? What'd you get? -4 over 5 to 14. Stacy's nodding. Jock's nodding. Blessing's nodding. Okay, let's see. Let's see if you got my stamp of approval. So what I'm going to do with this first power is multiply those together as well as multiply those together. So once I multiply those together, the big square brackets can go away because those 2 and 3, the 2 and 3 have been joined together. That's not a 3, it's a 5, right? Sorry. The 2 and 3 were joined together to make a -6. Still divided by, and then over here we have -4/5, and that becomes a -20. So that was the first step, using law 3 to multiply those guys. Now it's a division between the two. You have two identical bases. So when you're dividing two identical bases, the base stays the same, -4/5, but now you subtract. So you take the -6 and you minus off an already -20. That's actually -6 plus 20, which equals 14. And I told you just to leave it like that. There, done. Was that so bad? It looks scarier than it actually is, right? Do you guys want one more, or do you think you're okay? A thumbs up? That's a thumbs up, or okay? Okay. So, I want to just look at this assignment here. I might take off a couple questions. I just want to take a look first. 4, 7, 10. And then I'm just going to take off this guy. Okay, so just 4 questions from the textbook. Okay, if you really want to practice this stuff, well, you can certainly do this last page if you want extra practice, but I'll just write that it's optional. Okay, but the other 4 questions are not optional. So I'm going to now give you until 12 to start working on this. So in about half an hour, we're going to start up again, and we're going to do a few more examples that this time contain variables, letters.